Sometimes when you look at the night sky, you can see a star that glows in the dark. The crescent moon can also be seen. But in some parts of the world you can see beautiful multicolored waves of light shining. It is best seen in the polar regions. The light seen at the North Pole is called northern lights, and the light seen at the South Pole is called southern lights. Italian astronomer Galileo Galilei named this light Aurora Borealis in 1619. Aurora is the Roman goddess of the dawn, while Boreas is the Greek god of wind. The southern hemisphere's equivalent of the northern hemisphere's Aurora Borealis is the Aurora Australis, sometimes referred to as the southern lights. Now let's see how this aurora is formed. A type of charged particles are emitted from the sun at a speed of 72 million kilometers per hour. As these particles approach Earth, our Earth's magnetic field deflects this particle towards the north and south poles. These charged particles entering the polar regions excite the gas atoms and molecules in the atmosphere. Thus excited gas atom and molecule have high energy. But they should return to its normal state. While returning from the high energy state to the normal state, they emit light. It is this light that we see in our eyes. The color of the aurora varies depending on the composition of gases in the atmosphere. The Earth's atmosphere contains approximately 78% nitrogen, 21% oxygen, 0.93% argon, 0.04% carbon dioxide. Neon, helium, methane, krypton, ozone, hydrogen, water vapor etc. also present in atmosphere in small amounts. The most common aurora color is green. Green auroras are usually formed when the charged particles collide with oxygen molecules in Earth's atmosphere at altitudes of 100 to 300 kilometers. Because the human eye is so sensitive to the color green, we see the green aurora better than any other color. Red auroras are relatively rare. They are usually formed by intense solar activity. These red auroras occur when solar particles collide with oxygen at high altitudes, typically 300 to 400 kilometers. Blue and purple auroras are less visible than red ones. These colors are created when solar particles collide with nitrogen, at a height of 100 kilometers or less, in Earth's atmosphere. Yellow and pink auroras result from the combination of red auroras with green or blue auroras. Auroras also occur on other planets. An atmosphere and a magnetic field are required to create the aurora. Auroras have been discovered on both Venus and Mars, which have very weak magnetic fields, and scientists have catalogued 3 different types of Martian auroras. One occurs only during the planet's daytime. The other is a widespread nocturnal feature triggered by strong solar storms, and the other occurs sporadically at night. Jupiter's magnetic field is 20,000 times stronger than Earth's, so the giant planet's auroras are much brighter than those seen on Earth. Jupiter's auroras are not produced by the solar wind alone. Its closest moon Io emits particles in space by volcanic eruptions, also create auroras on Jupiter. Auroras are also thought to be common in the skies of exoplanets. Another aurora-like phenomenon on Earth is STEVE, strong thermal emission velocity expansion. Like the northern and southern auroras, STEVE is a luminous atmospheric phenomenon, but it looks slightly different from the aurora. These emissions appear as a narrow and distinct curve, usually purple in color and often including a greenish structure, that slowly moves westward. STEVE is visible in areas closer to the equator than the auroras. We will discuss some widespread misconceptions regarding these auroras in our next video. Kindly be sure to subscribe to our channel if you want to receive notifications when new videos are posted.